Hello everyone, in this video we'll be covering the basics of classes, more specifically the constructor and the destructor. We will be creating a class called shape2d, and this will be done in C++. So the way that we want to begin is that first we want to add a new file, and this is going to act as our main. So I'm going to call this main.cpp. It's a C++ file, and we'll add it. So here we have our main, and the best way to start all our main programs is to include our standard library, which is iostream. I will create an int main, and I will say that we'll just leave it empty. So I'll say return 0. So here we have an empty main, and this will be used to test our class. And one thing that one person may do, a programmer or code that you may find, is that people will declare the class here. I don't like to do that. I like to keep things separated into different C++ files, just in case I'd like to reuse the class. So we will not be putting our class in the main.cpp, but we will be creating our class in a different C++ file. So I like to begin my classes by creating a header file, and I'll call this as my shape2d. Okay, now that I've created this header file, now what I'd like to do is include the standard iostream, and what I'd like to do after, right before I go about implementing details about my shape2d class, is that I like to include my shape2d inside of the header file. Right now it's included. Now when I test main.cpp and create my class, I don't have to worry because I already included it. And I don't have to worry about making the mistake of implementing a class and not including it and have our compiler freak out. Alright, but with that being said, when we want to create a class in C++, we use the class keyword and then the name of our class. I'm going to call this shape2d, and I open my braces, and Visual Studio is nice because it automatically creates a closing brace for you. So here in this header file, I'm just going to declare the contents of my class. So I'm going to use the private keyword, which is going to contain the data in here that's going to be private for my class. More on private data in a future video, but here's going to be similar to a structure. I'm going to create some variables that I like to keep consistent track of, and typically when we create data in the private section, it's data that's quite connected with the class, right? When we think of a 2D shape, it's going to have a length and a width, and that'll be the only two variables that I'll be dealing with for this class. Of course, you as a programmer, you have the power and the control to create as many as you want. So here I'm going to declare a constructor, which is one of the main topics that we'll be covering, as well as a destructor. Right, and that'll be it for our class. Here we've declared it. We declared our private data, and we have a length and a width, and this will belong to the class. And I'm actually going to put an underscore right there before it, so that way I know this is part of the class. And you see there's a comment here about our constructor and destructor, and it's going to complain that there's no implementation of it. So we will solve this problem by going and creating a new implementation. So in our source files, we'll be adding a new item. It's going to be a C++ file, and I'm going to call it shape2d. This will be the implementation of our shape2d class. Now, because we are implementing on another file, I need to include the same header file, the my shape2d.h. And actually before it, I need to include iostream. Right, very important header files. What? Oh, that's iostream. So now that I want to define the specific constructor of my class, I need to specify that this constructor that I'm specifying is going to be part of my shape2d class. So the way I want to show that is I say shape2d : and well, Visual Studio is nice because it shows you what belongs to the shape2d class. Here I'm going to be dealing with the constructor, so shape2d. Okay, so what is the point of the constructor? The constructor is called at the beginning of life for the class, right? So when we create our shape2d class in main, if I go here and I say shape2d and I say my shape. Okay, here I create a shape2d class and it's called my shape. What's going to happen? And by what I mean that is that what's going to happen to length and width? What are we going to do? Do we need to do anything? Well, yes, in this case we do, because length and width have no way of initializing themselves. And we want length and width to always have values, so that way nothing unexpected can go on. So we'll define that in the constructor. So here I'm going to say length is equal to 0 and width is equal to 0. Right? So now when I create my shape, it's going to have its own internal variables, in which I'll write in comments here, my shape. So if I look at my shape dot length, that's actually going to be 0. Because in my constructor, since it's called at the beginning of life for the function, is going to initialize my length and width private members to 0. And this is really convenient, so that way when I use my shape2d class, I don't have to keep initializing it in my main code. I can leave the initialization to something else. And one problem that I might have with this constructor is that this always initializes it to 0, and I don't always want it to be that way. So I'm going to create another constructor, and I'm going to say it's going to have an input of length and width, right? So this here is going to be our unparameterized default constructor. It's unparameterized because it has no parameters, and it's the default constructor because it is the first constructor that will be called when we call the class. And again, this is the constructor because it has the same name as the class. Here we have our parameterized default constructor, right? So here I will have two options in creating my constructor, and let me show you what that looks like. If I have shape2d, I will say my second shape, and I don't know, 5 and 6. Okay, this will call my unparameterized default constructor, and this will call my parameterized default constructor. So let's go about implementing our parameterized default constructor. Again, this parameterized default constructor belongs to the shape2d class, so I need to tell my compiler that this belongs to the shape2d class. Now I'm going to replicate the input variables, length and width, and now we're going to start implementing it. Now, Here with these parameters, we want to assign them to our private data, but we can't exactly trust that the users will implement the right data. If I go to main here and actually type -5, well, I can't have a length of a two-dimensional shape that's negative. That doesn't make sense practically, right? This might be a geometry library that I might be writing, and if any of the shape's dimensions is negative, it will break. I mean, it doesn't make sense to have a shape with a negative type of length or a negative width. So with that, and we'll test it here, I'm going to kind of exert control over how I can assign data to my private data. So I'm going to say if length is less than 0, meaning that it's negative, I'm going to say that underscore length is going to be equal to length, well, to negative length, meaning we'll flip the sign. Well, actually, I'll just say length times -1. Right, so we'll flip the sign of length if it is negative. Otherwise, I'm just going to say length is equal to length. Next, what comes is I want to check width if it's less than 0. I will say width equals width times -1. Otherwise, it passes our test. And that'll be it for the parameterized constructor. Something that you, the user, may be noticing is that I have nothing to check if it's equal to 0. And that's something that I can check for, and actually I will in this program. But the idea of these type of constructors is that you have control over, actually I'm gonna move this code here. Makes sense to move this here. I want to check if it's 0 first. But anyways, the principle is that you as the programmer get to control how other programmers or other users, maybe the user of your program, can access data and how they can manipulate data. You exert control. You're able to put restrictions, right? So for here in this case, if length is equal to 0, I actually want to set it to 1 because I want something that's positive, or positive that's greater than 1. And if it's negative, I want to flip the sign. So I'll fix this and I'll get back to you when this is done. Okay, now that this is done, all that's left is that we have to take care of our destructor. And what is a destructor? Well, the destructor is called at the end of life for the class. And in our case, we don't really have to do anything for the destructor. But for example, if I had something like a dynamically allocated array, in the destructor, here's where I would free the memory. Or if I had a class that had a network connection, in the constructor, I would make the network connection, and in the destructor, I would disconnect from the network. Right, your destructor cleans up all the data and all the actions that you've done, or right, it finalizes in destroying or getting ready for the compiler to destroy the data that's here. Since I have two statically allocated variables, the computer can take care of it for me and it can destroy them for me. So here I will define my shape 2D, and here I'll actually specify that I am working on the destructor. And for this case, I will just print that the class is being destroyed. right? Other than that, you could put a semicolon, or you can actually omit it. Something to note is that with C++, when you create classes like this, you don't always have to define the constructor and destructor. Your compiler can actually create one for you. However, beware, you and your compiler may have disagreements on how to implement these classes. So if you're ever in doubt, create your own constructor and destructor. In the next video, we'll be covering the use of copy constructors. Thanks for watching.